Hello, this is part 3 of a video playlist about the preparation of alkenes. In this video, we'll have a look at the elimination of amines and various derivatives of amines. Carbon-nitrogen bonds are strong, and most amine derivatives do not undergo elimination readily. Nevertheless, occasionally CN bond cleavage can be a useful strategy for preparing olefins. If a primary amine does not undergo thermal, acid or base catalyzed elimination directly, it will have to be activated either by quaternization or by single or twofold acylation or sulfonylation. During the fragmentation of quaternary ammonium salts, the anion can have an impact on the outcome. Ammonium iodides tend to yield alkyl iodides instead of olefins, but this can be avoided by adding an excess of sodium hydroxide to the reaction mixture. Otherwise, the mechanism and structural requirements of these eliminations are similar to those of the elimination of hydrogen halides discussed in part 1 of this playlist. The main difference is that CN bonds are more difficult to cleave than carbon-chlorine or bromine bonds. Primary amines readily react with nitrous acid to diazonium salts. Elemental nitrogen is about the best leaving group known, and aliphatic diazonium salts immediately fragment into a carbocation and nitrogen, even at low temperature, unless deprotonated to a diazoalkane. Unfortunately, such reactions mostly yield mixtures of alcohols, alkenes, and rearranged products and are only rarely useful for synthesis. Aliphatic amines do sometimes readily eliminate ammonia or amines, but only if the starting amine contains an electron-withdrawing group in position 2. Some electron-rich diaryl methylamines are also sensitive and can undergo solvolysis with acids. In this example, N-cyclohexylacetamide underwent CN bond cleavage when heated with phosphorus pentoxide and xylene. As a byproduct, acetonitrile was formed. This reaction probably proceeded by complete dehydration of the acetamide, followed by elimination. N-dialkylacetamides do not yield olefins under these conditions. N-alkyl N-nitrosamides are easy to prepare by nitrization of amides, for instance with sodium nitrite and acetic anhydride. These nitrosamides are synthetic precursors of diazoalkanes and diazonium salts. In this example, a nitrosolactam eliminated nitrogen when heated with catalytic rhodium acetate, and a high yield of a terminal alkene resulted. I've sketched here one possible mechanism analogous to the rhodium-catalyzed decomposition of diazoalkanes. Not all nitrosamides react this way. Simple refluxing in THF of the nitrosacetamide shown here yielded phenylacetylene, while treatment with rhodium acetate gave an enol acetate. Thus, it will have to be checked case by case if this strategy can be used to prepare a given alkene. Strained amines and their derivatives will undergo elimination more readily than non-strained amines. Here, a sulfonylacyridine was isomerized to an allyl sulfonamide by stirring with an iridium complex. Amines with bulky substituents are also strained and can become thermally unstable. Amines with two tertiary alkyl groups, for instance, may already fragment upon warming in toluene, as shown here. These eliminations are usually acid-catalyzed and tend to yield the thermodynamically less stable, less substituted Hofmann alkene. As usual, base-induced eliminations are facilitated by electron-withdrawing groups. Here, a secondary unactivated amine was eliminated from a 3-aminopropionate by heating with potassium hydroxide. Such eliminations proceed more readily the less basic the amine. Here, aniline was eliminated from position 3 of a ketone just by stirring at room temperature with 10% of a Lewis acid. The outcome of thermal or base-induced fragmentations of quaternary ammonium salts depends on the anion. Bromide or iodide can yield alkyl halides instead of alkenes, while hydroxide, fluoride or cyanide will increase the yield of alkene. In this example, heating of tetrapropyl ammonium fluoride led to propene, tripropylamine, and a thermally more stable ammonium bifluoride. Instead of preparing and isolating a salt with a non-nucleophilic anion, the elimination can also be conducted in the presence of an excess sodium hydroxide, as in this example. Here, a conjugated triene was prepared by Hofmann elimination of dimethylbenzylamine from an ammonium bromide. In this example, quaternization with methyl iodide and elimination occurred in one pot. The carboxyl group, of course, greatly facilitated this elimination. Here, a quinone methide was generated by refluxing 4-methylbenzyl trimethylammonium hydroxide in toluene. Most of the intermediate polymerized, but a small amount dimerized to a strained paracyclophane. Ring strain can also promote Hofmann eliminations, as in this example. Treatment of a quaternized 3-chloroacetidine with potassium tersbutoxide yielded a chlorinated allylamine without any dehydrochlorination. Occasionally, amines are cleaved to alkenes under surprisingly mild conditions. Here, for instance, while trying to prepare a hydroxymethylpyrrolidine-derived tosylate, a mixture of an alkene and the target tosylate was obtained in low yield. The alkene was probably formed by initial tosylation at nitrogen, fragmentation, and formation of formaldehyde. Let's check some further potential side reactions. Treatment of quaternary ammonium salts with bases sometimes causes formation and rearrangement of an ylide. One of these rearrangements is the Stevens 1,2 rearrangement, which is similar to the Wittig rearrangement of methylated ethers. In this example, this reaction was used to prepare a substituted morpholine from a quaternized aldehyde aminal. Similar to the Stevens rearrangement is the Sommerlet-Hauser rearrangement, in which the methylated carbon atom of a benzylic ammonium ylide attacks the arene. In this example, the intermediate ammonium ylide underwent both Stevens and Sommerlet-Hauser rearrangement. It should also be kept in mind that strong bases sometimes eliminate sulfinate from sulfonamides, as in this example. And methane sulfonamides are acidic at the methyl group and might be cleaved by bases through intermediate formation of sulfines. Here are a few more references which you can also find in the description of this video. Under the Community tab, there's a PDF version of this presentation. In the next video of this playlist, we'll have a look at the preparation of allylic alcohols by ring opening of epoxides. The latter are readily accessible intermediates. So don't miss it.